Section 7.3, sum and difference identities. We start off with a couple of cosine identities. We've got the cosine sum and the cosine difference. I don't know that you'll have to remember this or memorize this, but it helps kind of to know the pattern. If I'm looking at a cosine, notice it goes cosine, cosine, sine, sine. Okay? We're talking about sum of two angles, A plus B. A is an angle and B is an angle. And then notice that if it's a cosine sum, then it's cosine, cosine minus sine, sine. You kind of start seeing these patterns pop out of these formulas. And it helps you to memorize it even if you're not really trying. Okay? So on the other one's a cosine difference. That means like an angle minus an angle. 45 minus 30 or something. Okay? And then you notice cosine, cosine plus sine, sine. That's kind of something to look for. Might help you to memorize even if you don't try. So example 1, find the exact value of cosine 15 degrees. Okay? We've never been able to find the exact value of cosine 15 degrees before. We've been able to plug it into our calculator, but we've never been able to use the chart to find cosine 15. Okay? But now we're going to be able to do that because we would be able to change 15 degrees into a difference problem. Okay? I could use numbers in the chart, numbers that I know, for instance, 45 degrees minus 30 degrees. Okay? I'm going to be using angles that I know about, 45 and 30, to figure out one that I didn't know was 15. Okay? Cosine 15 degrees equals cosine of 45 minus 30. Certainly you know that that's true. Okay? But using our formula, go back and look at our cosine difference formula. The cosine difference formula, that'd be 45 minus 30 there. Okay, so we've got cosine of the first one, 45, cosine of the second one, 30, plus sine of that 45, sine of that 30. Okay, it's just a pattern. Okay, it's just a pattern. And so the formula says cosine 45 degrees, cosine 30 degrees. Instead of minus, we say plus. Sine 45 degrees, sine 30 degrees. So it's a little bit complicated for our formula, but it's just a pattern, and we're going to just plug in things that we know. Okay, so look at the chart. You should be able to tell me really quickly, what's cosine 45 degrees? Square root of 2 over 2. And cosine 30, square root of 3 over 2. Plus sine 45, square root of 2 over 2, and sine 30 is 1/2. And so if we clean this up, okay, just clean up your fractions a little bit. We have square root of 6 plus the square root of 2. Both of those things we know over 2 times 2 is 4. Okay. The exact value, cosine 15 degrees, the square root of 6 plus square root of 2 over 4. Okay? Now the exact value of cosine 5 pi over 12 is a little bit harder. It's harder because we're not as good with radians and we're not as good with fractions, but it's still the exact same concept. Okay? If we're looking at cosine 5 pi over 12, what we want to do is make that into a sum or a difference. Okay? And so how we're going to do that, how I would like to do that, is you look at your angles in the chart. You got pi over 6, pi over 4, pi over 3, and pi over 2. It's very difficult to see how to make 5 pi over 12 out of that. Unless we do what we've done a lot in this class and talk about common denominators. Since my problem has a denominator 12, let's make all of these have a denominator 12. So I'm talking 2 pi over 12, and what would that be, times 3 would be 3 pi over 12. All I'm doing is times 2 over 2, times 3 over 3. I'm trying to get a denominator 12. Okay, times 4 over 4 would be 4 pi over 12, and times 6 over 6 would be 6 pi over 12. If you will look at a common denominator for our angles in the chart, it's not terribly difficult to see how to produce 5 pi over 12. If I just added those two, if I added 2 pi over 12 plus 3 pi over 12, that would equal 5 pi over 12. Okay? And so what I'm going to do is use a cosine sum. So I'm not going to say 2 pi over 12 and 3 pi over 12. I'm going to use the reduced versions, pi over 6 plus pi over 4. Okay? Pi over 6 plus pi over 4 is the same thing as 2 pi over 12 plus 3 pi over 12. And so you convert my problem, my cosine 5 pi over 12, into a sum cosine pi over 6 plus pi over 4, and then use your cosine sum formula. Cosine sum says cosine of the first one, cosine of the second one, minus sine of the first one, sine of the second one. So the hardest part for me is getting that fraction, getting that common denominator, finding that sum. So then cosine pi over 6, just look at your chart. That's square root of 3 over 2. Cosine pi over 4, square root of 2 over 2. Minus sine pi over 6 is 1/2. And sine pi over 4, that's square root of 2 over 2. Going straight from the chart. And so then cleaning up my fractions again, I've got the square root of 6 minus the square root of 2 all over 4. So cosine 5 pi over 12 equals that. Okay. Now then part C says find the exact value of cosine 87, cosine 93 minus sine 87, sine 93. It's the same thing, it's just backwards. Okay, it ought to be easier, but people kind of struggle with this one, I suppose. But look at which formula it is. Okay, did you notice the minus? Did you notice the minus in there? Okay, that would indicate that we're talking about a cosine sum. This must be a cosine sum formula, and so basically what we have is a sum. Cosine 87 plus 93. I used the exact same formula. I just used it backwards. I noticed this minus sign indicated that I was going to have a plus right here. So 87 plus 93 is what? 180? I'm looking at cosine 180 degrees and cosine 180 degrees. You should know this. Okay? 180 degrees puts us over here. I'm looking at the x coordinate of that point over there at 180 degrees. Here's 180 degrees. The x coordinate is -1.